during a process, you have to transport the fluid from one vessel to other vessel through long pipes. In such a case, you should have a device or an equipment which can help you in transporting the fluid. So pumps are that equipments which can help you to transport the fluid from one vessel to another vessel. That's the reason why pumps come into picture in fluid mechanics. This is the schematic of a pump. You have an impeller. It is driven by an impeller. The fluid coming in, it goes to the eye of the impeller. They call it as eye. This small circle is what we call as the eye of the impeller. This is where the fluid, the suction point is. The fluid enters through here, and through the impeller it goes to the exit. That is where discharge is. Pump has suction and discharge. Suction is where the fluid enters, and discharge is where the fluid gets out. Since a lot of energy is involved in delivering the fluid or in transporting the fluid, the energy requirement for a pump depends on certain factors. First is the height through which the liquid is raised, and the second one is the pressure requirement at a delivery point or at a discharge point or at the location where you wanted to take. The third requirement is the rate of flow. Fourth requirement, the length and diameter of the pipe so as to maintain the pressure. The pressure drop depends upon the length and diameter of the pipe, that is the diameter of the pipe. And last but not the least, the physical properties. Density, viscosity, the flow properties. That is what I mean by physical properties. There are, depending upon their motion, you have two types of pumps. One is the positive displacement pump and the other is centrifugal pump. Reciprocating pumps and rotary pumps comes under the category of positive displacement pumps, wherein they take the reciprocating action or the rotary motion to transport the fluid or to take the fluid. These pumps are used to handle whenever you have very viscous liquids and whenever there is a precise control requirement. They operate at constant flow but with variable heads. And it has some limitations. It can operate only at a limited flow capacity, but however, it can handle relatively high pressures. So these are the advantages of using the positive displacement pumps. They are basically dependent on the reciprocating action or the rotary action of the pumps, of the impeller. Next comes the centrifugal pumps. The transfer of energy from impeller to the fluid takes place by angular momentum. Here it is by reciprocating motion, there it is by angular momentum. These also operate at constant flow but with variable head. The main advantage of centrifugal pumps over the positive displacement pumps are it works under closed conditions. What do you mean by closed condition? You just close the discharge line and run the pump. During that case, what happens? The pump circulates the fluid and keeps it engaged without causing any damage to the pump. That is the advantage of using a centrifugal pump. And also you can operate in multi-stages. You can deliver the pressure in multi-stages. So that facility is also available in centrifugal pumps. Let's take locations. One is A and the other is B. The difference between the heads between these locations we can estimate by using the Bernoulli's equation. P by rho G plus V square by 2G plus Z at point B minus P by rho G plus V square by 2G plus the elevation at A. So, neglecting the velocity, kinetic energy and potential energy, hence the difference will give you the pressure drop. In this context, it is good to introduce efficiency, we call as pump efficiency, which is given by rho G delta H in the theta by brake horsepower. Brake horsepower is the power required to drive the pump. So pump efficiency is calculated by this formula, and the head is given by this formula, which is obtained by applying the Bernoulli's principle and neglecting the potential and kinetic energy heads.